All right, so let's recap that about the layer 2 one, which I have already told you, right? So you see that these are the high-end switches, catalyst switches of the Cisco. So currently there is no link between these two uh, switches. So interfaces will be by default down. All right. So by default the interfaces will be down. What I will do, I will first go ahead here. If you see that in the switch one, let me assign the name switch one. And if I say do show IP interface brief, and you see that its status is down. All right, let me go to the switch 2 now. You see that interface status is down. So what I will do is that I will just go and add a link. That's it. I will do nothing. I will go ahead, connect the link. That's all. I did nothing. You just wait and you see that the interface came up now. If I go here also, it's the same. And if I say do show IP interface brief, and you see that the interface has came up now. All right, so this is the behavior of the switch normally, right? Because if the link is being removed, it will automatically uh, the interface status will go to the down status. All right, so I was trying to demonstrate the same thing with the L2 switches, which were not happening, if you remember. So now it is all good. Okay, so these switches are good, which are the layer 3 switches we say. All right, so today's agenda for the lab, what I want to really show you is the important thing about the port channel. So I have already showed you the port channel, but again in this one I will show you properly how things work. So now my switch 1 and switch 2, these are my two switches. I'm going to connect these two interfaces and I'm going to make this one as a port channel 1. After that I will connect one more switch, that is switch 3, and I will connect two links from this side and two links from this side. Alright, so on every switch what I will do, I will create two interfaces, port channel 1, port channel 2, port channel 1, port channel 2, and port channel 1 and port channel 2. And both the port channels will be the trunk ports, because if I create the VLANs, all the switches should have the VLANs and they should be able to communicate with each other. That is my agenda. So after configuring this one, so I will say that this link will be the port channel 1, this link will be with the port channel 2. Again with this switch, this link will be the port channel 1, these two links will be port channel 2. With switch 3, I will say this one will be the port channel 1 and this one will be the port channel 2. So this will enable me to have all the links up and running. And after that, I will connect one PC over here on a VLAN number 10, and I will connect one more server, one more router over here, which will be on a VLAN number 20. And here I will install one router which will be acting as a default gateway for VLAN 10 and VLAN 20. And I will use a sub interfaces over here. For a default gateway will be 254 for both of them. And for VLAN 1, I will assign the IP address from the subnet mask 10.1.1.1. And for the VLAN 20, I will assign from the subnet 20.1.1.0. Okay. So at the end of the lab, what I should be doing is that I should be able to ping from PC1 to my server router. And if I remove these two links, my failover should happen. That means these two links should not affect my traffic. Some packets will be dropped, that's fine. But again, it should automatically transfer the, what do we say, the path. It should automatically shift the path, whatever the path it is available, and should be able to communicate with server 2. Sorry, server. All good with the explanation? What we are going to do now? All right.
Yes. But can I speak because if you're recording, it will be
Yeah, I'm
distant.
already recording, so don't worry about it. All right.
Yeah, but if I speak in the middle, it will affect, right?
Nah, that's
So
all good.
I'll
Yeah, that's all good.
all good. Okay.
Yeah, we're having an interaction over here, discussion, so that's all fine.
Okay. Thank you.
Okay, so this is my agenda. If you have any doubt at any point, let me know. Now, the interfaces which I'm going to use will be gig 0 slash 0 will be connected to gig 0 slash 0, gig 0 slash 1 connected will to gig 0 slash 1, and which switch 1 gig 0 slash 2 will be connected to gig 0 slash 0, and gig 0 slash 3 will connected to gig 0 slash 1. And here also gig 0 slash 2 will be connected to gig 0 slash 2, and gig 0 slash 3 will be connected to gig 0 slash 3. So it doesn't matter what the interfaces are there. Okay. Main thing is that I will create the port channel. These links will be participating into port channel. Then we will create the VLAN 10 and VLAN 20 on all the switches. And after that, I will install the router over here with the sub interface, which will be acting as a default gateway. So my traffic will be coming like this, hitting my default gateway. From here it will go like this, and after that I will just remove these two links so that my traffic should go in this way and go in this way. Alright, so let me go ahead. So I have already, you see that I'm creating the topology now. Okay, this is my switch 3, 0 slash 2 connected to this one. Alright, so now one more thing you should be knowing is that I will just now what happened if I have my switch 1 connected to switch 2 and connected to switch 3. All these four links are participating in port channel 1. Okay, everyone is
Mm-hmm.
participating in port channel 1, port channel 1, so port channel 1. So what happening is that in every switch there are four links connected. Okay, but the whole four links will not be up and running. So there will be something called as HTTP that will block some links. Right, so block some links means, for example, it might say that, okay, these links, I want to block it and I want to allow the traffic from this side. So that's the reason I'm creating different port channel 1 over here, port channel 2 over here, so that it doesn't block the traffic. We can utilize the whole bandwidth. All right, so I have connected these things. So let's go ahead and configure now. So I'm in switch 1 now. On the switch 1, what I will create is that interface port channel 1. I will say trunk switch port trunk encapsulation dot one q switch port mode trunk and exit. This is what it is. Port channel 2, same thing. Switch port trunk encapsulation dot one q switch port mode trunk, and that's it. So I've created two interfaces port channel which are layer 2 interfaces which will be acting as a trunk. That means as I created the VLANs, it will automatically add that VLANs to this particular port channel. I will also show you when it will be added. Now I will do the same thing. So if I say do show run interface port channel 1, this is the configuration. So I will just copy these two commands, go to switch port 2, interface port channel 1 and paste it over here. Interface port channel 2, paste it over here, and that's it. I will do the same thing for the switch 3 also. Interface port channel 1, paste it, and interface port channel 2, paste it. Now it's time to configure my links now. So as per my diagram, I will write down the links over here also. Gig 0 slash 0, gig 0 slash 1, now gig 0 slash 2, gig 0 slash 3, gig 0/2, gig 0/3, connecting to 00. Alright. So gig 0/0 and 0/1 should be belonging to port channel 1. So that is what I will do in this one. So I will say that interface range gig 0/0 to 1, switch port trunk encapsulation dot 1q, switch port mode trunk, and I will say that channel group 1 mode will be active and exit. My link should go down because one switch is participating in the port channel, other one is not participating. So that's why it is showing you down. All right. So and also it's saying that the other device is not running port channel plus LSAP. So I will go to the switch 2 now. Interface range gig 0/0 to 2. Sorry, 0 to 1. So if I have given 0 to 1, yep, that's correct. 0 to 1. Switch port trunk encapsulation dot 1q, and I can just directly say channel group 1 mode active and exit. So if I don't give the command this one switch port mode trunk, that's fine. And as soon as I have the other switch is participating in the port channel, now the interface came up. So if I say that do show ether channel summary, so currently gig 0/0 and 0/1 are participating in my port channel. So that means this link is now up and running. Now let's configure this ring now, gig 0/2 and 3. And finally I will configure the switch 3 at the end. So I will say that interface range gig 0/2 to 3, switch port trunk encapsulation dot 1q, and I will say that channel group 2 mode will be active and exit. Now switch 3 is not participating in port channel yet, so the interfaces will be down always. I
mm.
will save that config. Now I will go to switch 2 also, interface range gig 0/0 to, sorry, 2 to 3. I will say switch port trunk encapsulation dot 1q, and channel group 2 mode will be active and
What
exit.
is this channel group?
So that is a command to tell the interfaces that you are going to participate in the port channel number 2. So I've created port channel
Okay.
1 and 2, right? So this is the
Mm.
number which will define. And mode active means we are asking them to run the LSEP protocol, which will be helping into the VLAN tagging and the STP.
Mm.
All right, so now if I go to the switch 1 and if I say do show ether channel summary, two ports will be up but two ports are down, which is going to the switch 3. They are in suspended mode. Now let's go to the switch 3 and configure that one now. I will say interface range gig 0/0 to 1, switch port trunk encapsulation dot 1q, switch port channel group 1 mode will be active and exit. Interface range gig 0/2 to 3, switch port trunk encapsulation dot 1q, and channel group 2 mode will be active and exit. I will save the config. And now port channel 1 was participating, so it came up. And now port channel 2 should be participating and it came up. So if I say do show ether channel summary, I should see all the four ports are up and running. So P means up and running. So participating in port channel, do show ether channel summary. And here also I should see all the four ports are running that one. And now here I will say to show ether channel summary. All the four ports are running, right? So now if you see according to my service, according to my setup, this is, you can say this is my core now. The whole thing is like acting as a core. Because if any link is down, there is another alternative path. My core is ready now. So now let's create the VLAN 10 and 20 on all the switches now. To create that one, it's pretty easy. So I will just say VLAN 10, comma 20 exit, and I will say that VLAN 10, comma 20 and exit. I will go to switch 3 and I will say that VLAN 10, comma 20 and exit. And now, after you create the VLANs, if I say do show VLAN, now the problem here is that you see that port channel 2 is still belongs to the default VLAN. It doesn't happen in the physical device, but this is a virtual device, so that's why I have to check it. So it still belongs to the VLAN number 1. It is not trunking. If I say do show interface trunk, you see that port channel 1 only is participating in trunk. So
Mm.
commands are still the same, but it's only that we have to do one more time. That is port channel 2, switch port trunk encapsulation dot 1Q and switch port mode trunk and exit. And if I say do show VLAN this time, now you see that it has removed from that. And now if I say do show interface trunk, and now I should see both the port channels are now doing trunking. Trunking is important because as you create the VLANs, it will forward that VLAN traffic, otherwise it will not forward. So be careful. I have to check on the same thing on that one, do show VLAN. And here also you see that port channel 2 is belonging. I was doing the lab in my while on the job. Port channel 1 and 2 both were assigned to the VLAN 1, but here still it's only one. If I say port channel 2 switch port trunk encapsulation dot 1Q switch port mode trunk and exit and save, and it should come up again. It came up. So if I say do show interface trunk, and now you see that port channel 1 and 2 are participating in trunk. So similarly for the switch 3 also I have to say do show interface trunk. Over here it's all good. You see that port channel 1 and 2 are participating. If I say do show VLAN, and that's all good. Switch 3 is good. It's only we have to check it on the 1 and 2. Alright, so at this moment VLAN 10 and 20 belongs to are present on all the switches now. Now I will go ahead and connect one my default gateway router over onto the switch 3. Over here I will connect one router here. So if I go back to my topology, I will grab one. I will just rename this one as a default gateway, and I will turn on and I will connect it to the gig 1/0 interface. Now, this interface should also be a trunk interface, trunk link, because this router will be acting a default gateway for both VLAN 10 and 20. So let's make the on switch 3, you see that it came up now, gig 1/0. I will say that interface gig 1/0 switch port trunk encapsulation dot 1Q, switch port mode trunk and no shut exit and save the config. Alright, so once you save that one, so first thing is that I have to confirm whether that link is been added to trunk interface or not. Do show interface trunk, and now you see that that is been added to the trunk. So that means this link is now a trunk link, so now I can go ahead and configure my router. So the router is on 5006. Okay, so I'll just put this one. Okay, so it is coming in, so I will just increase the font. Alright, so my router is up and running, so let's configure the router. I will say interface E0/0, no shut first, so that my
Mm.
interface will come up. And after that, I will say interface E0/0.10 encapsulation dot 1Q. That is, I'm saying that tag this traffic as a VLAN number 10. And then I am saying that IP address will be 10.1.1.254 exit. Interface E0/E.20, 0.20. I'm saying encapsulation dot 1Q20 and IP address will be 20.1.1.254 if I say do show IP interface brief, and now you should see that I have two sub interfaces now. Now my default gateway is also ready. So next what I'm going to do is that I'm going to add one router over here which will be acting as a server, and I will add one PC over here, and after that I will try to ping from here to here, continuous ping, and I will remove the links and see what is happening. So I'll go back to my topology. I will grab one more router and I will rename that one as a service server, and I will connect to gig 1/0. Now this will be the VLAN interface, not a trunk interface, because this belongs to the VLAN number 20. And I will grab one PC that should be the PC1 that will be belonging to VLAN number 10. Alright, so SRV is on 5007. Okay, have that one. Alright, so now I will configure this router now. I will say that interface E0/0 IP address will be 20.1.1.1
Mm.
and no shut exit, and I will give a default gateway which is my router 20.1.1.254. That's it. I will just enable the IP HTTP server, IP HTTP or 10. Alright, so just enable the HTTP server on this one. That's it. Alright, so I have configured my router, but currently I have not configured this interface as a VLAN number 20 interface. So that's why if I try to ping 20.1.1.254, it will not ping, because by default it will belong to VLAN number 1 and it will not forward the traffic over here. So let's go ahead and configure that one on switch number 2, and I will say that interface gig 1/0 switch port mode access, switch port access VLAN number 20 and no shut exit and save it. So once I have assigned a proper VLAN to that particular link, now if I go to my server which was not able to ping before, if I try to ping now, it should be able to ping. And also on the switch 3, did I make it? Yep, 10 and 20. Okay, still not pinging. Yep, it started to ping now. So it took a time and now it is able to reach. All good. So
Yes.
VLAN 20 is been fixed. So let's go ahead and fix our VLAN 10 also over here. Okay, so the VNC 5900. Let's say add a new entry. I would say VNC select. I would say this one should be PC1. Okay, let me see if that passed out or not connect. Alright, so this is my PC now. I will go ahead and assign the IP address to it. I will say IP address at 10.1.1.1/24 ETH0, and I will say IP route at default via 10.1.1.254. So all good. Let's go to the switch 1, and if I say that interface gig 1/0 switch port mode access VLAN number 10 and no shut exit, and that's it. So my configuration is good now. So I have assigned VLAN number 10 to this link, VLAN number 20 to this link. Everything should be good. So if I go back to my PC now and if I try to ping 10.1.1.254, I should be able to ping. And again, it will take some time, but after that it will, because as a behavior of a switch, it will forward the packet to all the interfaces, and the router will reply to that packet, and now after that we are able to ping. Now similarly, if I go to ping 20.1.1.1, which is my server now, so I'm just trying to ping from this side to this side now. I should
mm,
be able to ping because my routing is good, everything is good. So it's pinging now. So you see the number sequence number 1, 2, 3, 4, 5, 6, 7. It's increasing. Okay. Now let's go to our topology now. I will remove this one link and see if that makes any difference. So there is no difference. Still the traffic is going on even if I remove one link on this side.
mm,
I will remove one link. So I'm removing this link because the traffic will take this link anyhow because that is the shortest path.
mm,
I will also remove this link now. And now you see that at 37 it has stopped. So now what the switches will do is that they will think they will see that okay, there is some changes in the topology now. The link has been removed or maybe dead. So they will recalculate the traffic, how recalculate the path, and they will after that it should now the path should be now on a different the traffic should be forwarded to a different path. So it still stopped at 37 and it's still trying to calculate.
mm. How long will it take for it to get refreshed?
To be honest, don't remember switching that much now. So usually I think it will
Okay.
take 1 minute, I think, to converge. Okay, it came back now. So from 37, it directly dropped 50 packets. Now, what I will do is that I will go ahead and reconnect the links, both of them, and I will see if that makes any difference. Any traffic is being dropped. If I go back to my switch one, the port channel came up just now. All right, so it stopped at 114 for now. Again, it is reconverging now because the STP at the background will keep on tracking these VLANs. If any changes have happened, it will forward to all the switches. So after a while, again, the traffic will start flowing up. You see that started, the traffic is now continuing again. So 114th again, it dropped some packets, so it came back to 144. Right, so now if I want to go to the 20.1.1.1, I am able to visit the router also. So it says that 10.10.1 is accessing the router 20.1.1.1. Right, so that was your port channel lab, and that's how you configure the things. And this is now acting as a core. What I can do is that I can just connect different VLANs. That's all. I have to make sure that if I say, for example, I'm connecting one router here for the VLAN number 30, I just need to create VLAN number 30 on all the switches, and I can add over here one router, and again I can use the same link to create one more sub interface belonging to VLAN number 30, and it can act as a default gateway and it can communicate with the server as well as with the PC. Clear with this one now? Right, so if I go back to my switch and if I say do show ether channel summary, and all the ports are up, and if I say do show MAC address table, it should learn the MAC addresses now on different interfaces. So if I go to my default gateway and if I say do show ARP, and you see that 10.1.1.254, this is the MAC address 0100. So if I go to switch 1, what is this one? CC0 0100. So CC0 0100. So this is the one which is being learned on port channel 2. Okay, so why? Because if you see the topology, switch 1 over here, we have configured these two and a port channel. So that's why it is learning the MAC address of that sub interface on this port channel. All clear? Any doubts in layer 2 now? Switching and especially with the port channeling one. Now, one more term, whenever we are combining these links, we will say bundle ports or bundle links,
Mm-hmm.
or there is one more terminology that is aggregate links. So aggregate means nothing, just bundling or combining multiple ports links into one.
Okay.
I want to show you which I forgot. So if you remember in Cisco by default there will be CDP protocol running, LLDP will not be
Mm.
running. So we have to enable that
Mm.
one. So I will say LLDP run, that will enable that one. So what information do you see? So if I say do show CDP neighbor, and you see that I told you that it will get the device ID interface, and this is the, what do we say, CDP. So see, in CDP you got these three information. Let me enable the LLDP on switch 1, on switch 2, on switch 3, and now let me go ahead and say switch 1 do show LLDP neighbors. It's still discovering. So if I say do show CDP neighbors, so I have this information which says that R, that is a router mode, layer 3 interfaces. S, that means it is detecting a switch and it is links, the switches link can be a layer 2 and layer 3, so it's a router. And IGMP protocol, that means routing can happen on that particular link. So this is the extra information, and on what interface you are detecting those different devices, that is what it shows here. If I say do show LLDP neighbors, okay, still they did not learn anything, so it's taking time. But after taking the time also, still the LLDP will not give you this information, but it will give you this gigabyte port information, but the switch ID information. So by default, that is the IEEE standard. In most of the switches, by default, it will be running. Okay.